Selamat sejahtera Tuan. Hi, I am Jun Lim from Group 2. In this video, I'm going to talk about the procedure of mailing based on the understanding of our group. So in this video, I'm going to read out the procedure which is already written in the Google Docs by us with some explanation, pictures and videos for better understanding. Before I start listing my procedure, I'm going to show you this picture, which is the axis we are following in our procedure. And I would like to show you this picture, which is the name of the parts we are following in this procedure.
This mill has 3 axes. It has this handle, which moves the table left and right, and counterclockwise moves the table towards you, and clockwise moves it away from you. This handle moves the table forwards and backwards relative to the operator, which stands pretty much right here. It also has a Z-axis, which raises and lowers the table. This is the joint, the knee joint, which attaches to that axis, like so. And the up direction is marked on here. So clockwise raises the table, like so.
Just to clarify one more thing, we will be using conventional milling in this procedure to get a more stable performance. The first step is of course getting the aluminum workpiece from our lecturer. Then secure it in the vise. Scrape the corner of the workpiece to remove the metal residue using a flat file. Measure the dimension of the workpiece using a vernier caliper. Mark the parts that needed to be cut by using a vernier height gauge. Use face mill operation to get the dimension you desired. Since we are going to use the face milling operation, we first need to mount the face mill onto the vertical arbor. To do this, you need to engage the arbor in the machine spindle, unscrew the locking screw from the arbor, slide the ball of the cutter onto the arbor spigot, rotating the cutter to align the drive dogs to the cutter slot. Feel the drive dogs engage in the slot and face flat together. Hold the cutter in the position on the arbor and screw the locking screw into the arbor finger tight. Next, engage the dog of the key in the slot of the screw head and tighten the screw. After finish mounted the face mill, we will continue our process by aligning the vise and position the workpiece in the vise. Make sure to position the maximum length and depth of the workpiece in the vise to ensure the cutter will not fold the vise. Then, seat the workpiece and tighten the vise. To start our face milling process, slightly touch the surface of the workpiece with the face mill using the vertical movement of the crank and set 0 to the digital reader of the Z-axis. Move away the face mill from the workpiece by using the cross-transverse handwheel to move the Y-axis. Set the amount of depth of surface that needs to be removed by using the vertical movement of the crank. Set the turning speed of the milling machine at 750 RPM and turn on the machine. Feed the workpiece in a direction opposite the rotation of the face mill by using the cross-transverse handwheel to move the Y-axis. In other words, we are going to use conventional milling. Stop the milling machine and change the part of the surface under the face mill by using longitudinal transverse handwheel to move the X-axis. This is due to the procedure just now only help us to face mill one of the portion of the surface. So we need to use the longitudinal transverse handwheel to move the X-axis and make other portion of the surface be possible to be under the face mill and get cutted. Then, repeat step 18 to 20 until the whole surface has achieved the dimension desired. So we're going to repeat the procedure just now until the whole surface is being cutted. Next, repeat step 13 to 20 until every side of the surface of the workpiece achieve the dimension as desired. The workpiece we receive is a rectangular, which means there is 6 faces of it. So in order to achieve the dimension as we desire, we need to face mill 6 faces of it. Yes, until we achieve the dimension we desire, by using the procedure as I mentioned just now. After we achieve the desired dimension of the rectangular workpiece, remove the workpiece and use end milling process to cut the desired depth of slot. So as you can see in this picture, we need to have 2 slots of a depth of 5 mm. So in order to achieve this, we are going to use end milling process. The end milling process start with mount the HSS end mill on the vertical arbor by using the same step 7 to 12 that are used to mount the face mill before. We are using HSS end mill, which is high-speed steel end mill, because the workpiece we receive is made of aluminium. So we mount the HSS end mill onto the vertical arbor by using the same step as we mounted the face mill, and follow up with the step of align the vise and secure the workpiece in the vise. To start the end milling process, slightly touch the surface of the workpiece with the high-speed steel end mill by using the vertical movement of the crank and set 0 to the digital reader of the Z-axis. Next, move away the face mill from the workpiece by using the longitudinal transverse hand wheel to move the X-axis. Use the vertical movement of the crank to set the depth of the Z-axis to 1 mm. Even though the depth of both of the slot requires 5 mm, we are going to set it to 1 mm first to reduce it one by one, so that it's more safe and doesn't cause much burden to the machine. After this, slightly touch the surface of the workpiece with the high-speed steel end mill by using the longitudinal transverse hand wheel and set 0 to the digital reader of the X-axis. Use the cross transverse wheel to move away the workpiece from the high-speed steel end mill in the Y-axis. Set the X-axis to 10 mm by using the longitudinal transverse hand wheel. So we are setting the X-axis to 10 mm because the first slot is located 10 mm away from the side of the workpiece. Feed the workpiece in a direction opposite the rotation of the high-speed steel end mill by using the cross-transverse hand wheel to move the Y-axis. Repeat the step 26 to 32 until the depth of the 5 mm of the slot is reached. As I said just now, we are cutting the depth of the slot 1 mm by 1 mm, so we need to repeat the step until 5 mm is reached for the first slot. Then repeat steps 26 to 33, but for this time set the X-axis to 30 mm. So this is a step for the second slot, which is why we changed the X-axis to 30 mm, because the second slot is 30 mm away from the side of the workpiece. So we're going to repeat all the steps just now, but for this time we are setting the X-axis to 30 mm. And lastly, we remove the workpiece from the milling machine. That is all procedure you need to create a successful workpiece by using the milling machine. I hope my explanation is clear enough. Thank you, Tuan, for lending us your ears.